All right, guys, so I had a couple of requests for a video on this problem. It's section 3.2, question number 36. And it says the graph of f is given below. Use the graph to determine the following characteristics of f. If a solution does not exist, enter DNE. Use a comma-separated list to enter multiple values if needed. So the first thing it says is domain. So first thing it says is domain. So let's find the domain of this function. Remember, domain is all of our possible x values. So looking at this, I see that this graph goes down and to the left forever. So remember that this would be our negative infinity, and this would be our positive infinity. Notice that the left-hand side is going in the negative direction forever, the right-hand side is going to positive direction forever. So that's why those are negative infinities on our x-axis. So looking at this graph in general, our domain is going on forever to the left, so negative infinity. We can never reach negative infinity, so we're going to use a parenthesis. And then if you notice, it's stopping right here at 7. And at 7, there's going to be an open circle. So that means it's going to stop at 7, open circle, so that means parenthesis. Open circle, so that means parentheses. So that is our domain. So same concept for our range. Our range is now our y values. So again, this graph goes down forever. So it's going to go down forever. So it's going to go towards negative infinity for our y values. Comma, and then it's stopping up here. Nothing goes past this line up here at positive 8. So at positive 8, there is a point right here. So this is going to be a closed circle. So that means it's going to be a square bracket. So that is our domain, and that is our range. So moving down, I'm just going to erase this just for our, so we can start from scratch. Next, it says x-intercept. So x-intercept is where it crosses the x-axis. So there's one spot right here where it crosses the x-axis, and that's going to be at -5. So our x-intercept is going to be at -5. Let me erase this so again we can start from scratch. So we did x-intercepts, and now we're going to do open intervals where it's increasing, decreasing, and constant. So remember that increasing means that it's going to be moving upward. Decreasing means it's going to be going downward. And then constant means that it's flatlining out. It's going to be a solid flat line. It's not going up or down. All right, so looking at this graph, always read our graph from left to right. So if I see this graph going from left to right, I see that it's going upward. I see that it's going upward. And then until, oops, get this down. So I see this graph is going upward until right here, which would be +3. Because at +3, it stops going up and then it turns to go down. So this part over here would be increasing. It doesn't flatline because there's no like section of where it goes flat, it goes straight across, straight horizontal, but because it automatically goes down and it automatically goes to decreasing. It automatically goes to decreasing. So this left-hand side is going to be our increasing, and then this right-hand side is going to be our decreasing. So I had this line, but it looks like it's constant. Oh, shoot. So this is our 3, and this is increasing. All right, so it's going from negative infinity, going up, going up, going up, and then it stops at 3. We always want to use parentheses for increasing, decreasing, constant, because at that point of 3, it's going to go down. It's going to change. I don't want to include that endpoint of 3. Decreasing, it starts right here at 3, and then it decreases forever until this endpoint. This endpoint is at +7. Again, it said open intervals. Open intervals means open circles, so we are going to use parentheses for those. And there's nowhere where it's flatlining, so there's no constant. So just filling in our answers here. So increasing would be negative infinity to positive 3. Decreasing would be this 3 to 7. And then constant would be there is no constant, so does not exist. So D and E. So that's increasing, decreasing, and our constant. All right, so starting from scratch so that we can see my work. So open intervals on which f of x is less than 0 and open intervals on which f of x is greater than 0. All right, so looking at this, I know that f of x is the same thing as y. So it's saying when is y less than 0? So by the way, less than 0 means a negative. So when is y negative? All right, so let me move up. Oops. All right, so when is y less than 0? When is y negative? So let me just write it over here. So f of x is less than 0. We're looking for when y is less than 0. We're looking for when y is negative. So I see that our y values are negative on this piece right here. This piece goes down forever. So where is it negative? We're looking, we know it goes down forever, but it's asking where. It's always asking for your x values. We know y is less than 0, so we want to see those x values. So this is going from negative infinity, and then it's stopping right here at negative 5. So from negative infinity to negative 5. For negative infinity, we always use parentheses. And then for negative 5, notice my sign is just less than. It's not less than or equals to. So we are going to use a parenthesis there. And then same thing for the next one. The next one says, when is f of x greater than 0? F of x is the same thing as y. So it's asking when is y greater than 0? So it's asking when is y positive? So looking at my graph, I see that y is positive in this piece right here. We use a different color, but yeah. So this piece right here. So this piece right here is from that negative 5. And then it stops right here at positive 7. So from negative 5 to positive 7. Again, that positive 7 is an open circle. So open circle means that it's going to be a parenthesis. For that negative 5, it just says greater than. So that means it's going to be a parenthesis as well. If it said or equals to, we would include that number. We would include when this point right here is negative 5, 0. So we would include that point when our y value is 0, but it doesn't, so that would be that one. All right, so let's back. So here, what's this color? Open intervals mean parentheses on which f of x is less than 0. That's going to be that negative infinity to negative 5 with a parenthesis. And then open intervals on which f of x is greater than 0 is going to be that negative 5 to 7. Negative 5 to 7. All right, almost done. Okay, so next is going to be our maximum and minimum. So it says any x value for which f of x has a relative minimum. The value of any relative minimum of f is blank. And then it says the same thing for maximum. Any x value for which f of x has a relative maximum and the value of any relative maximum. So remember, we talked about this before. This first one says our x value. So this first one's looking for x. Then the next one is our y for our minimums. Same thing, the first one says our x. And then the second one will be our y's for our maximums. So we need to find our minimums and our maximums. All right, so looking at this graph, there is no minimum. The graph goes down forever. So because it goes down forever, there is no minimum point. There's no low point. Remember, if it's a graph that looks something like this, down here, this would be our low point. This would be our minimum, but there's nothing like that here, so no minimum. But we do have a maximum. So this point right here would be our highest peak. That would be our maximum. This ordered pair is 3, 8. So our x value is 3 and our y value is 8. All right, let's go there. All right, so the first thing is our minimums. We said there was no minimum, so this does not exist. D and E does not exist. All right, and then the next thing is our relative maximum. We said our maximum was at the ordered pair 3, 8, so x is 3, y is 8. This first one's asking us for our x value, so x is 3. The second one's asking us for our y value. Our y value is 8. All right, so the next thing says find f of -1. So this is saying, okay, when x is -1, what is our y value? When x is -1, what is our y value? Onto our graph. When x is -1, here we have it right here. What is this y value? Here's the point. This y value would be 6. This is the ordered pair, -1, 6. X is -1, y is +6. So for this point, our y value would be 6. X is -1, y is +6. Same thing for the next one. It says now the opposites though. So what is the x value for which f of x equals 8? So here it's telling us our y value is 8, but we don't know our x value, so we need to find our x value. So our y value is 8. Try to find an x value. So up here, whenever y is 8, our y value, whenever it's 8, here's our point. We said this x value was +3. So +3 would be that answer. Okay, here. So when x is +3, y value is 8. Last thing, is this even, odd, or neither? So we know that even means it has a y-axis symmetry, so I can fold it on the y-axis, it'll be the same thing on both sides. Odd means it has origin symmetry. So that means I can fold it along the x and y, like, okay, here's x and y. If I fold it twice, that's essentially folding on the diagonal. This diagonal is the equation y equals x. So if I fold it on the diagonal, it would be the same on both sides. But if I were to look at this graph, if I fold it on the y-axis, or if I fold it on the diagonal, okay, first of all, let's do one thing at a time. So if I fold it on the y-axis, if I fold it on this line right here, it's not the same thing on both sides. So it has no y-axis symmetry, it's not even. If I fold it on the diagonal to check for origin symmetry, it's not the same on both sides. So we have, it's not odd. So then our answer would be neither. So our answer would be neither. There we go. So that is all of number 36. I hope that this helps. If you have any other questions, please let me know. If not, thanks for watching.